class. Today we're going to be talking about work and how it relates in physics. So the definition of work in physics is when a force acts upon an object causing it to displace, meaning to move. And there's three main components when we're looking at when work is done in physics. We want to look at the force, the displacement, and the cause, meaning did that force cause the object to displace or move in the direction the force was applied in. So there's a couple scenarios I want you to think about, and as I read, I want you to think, is there work being done? A teacher applies a force to a wall and the wall doesn't move. A book falls off a table and free falls to the ground. A waiter carries a tray full of meals above his head across the room at a constant speed. A rocket accelerates through space. Alright, so going back to the examples, we're going to go through them. So a teacher applies a force to a wall and the wall doesn't move. Right then and there it says it does not move, meaning work has not been done because there's no displacement to calculate. So no work is being done. A book falls off a table and free falls to the ground. The book is falling, so there's a distance, and it's falling because of gravity, and gravity is a force. So yes, work is being done on that book. A waiter carries a tray full of meals above his head across the room at a constant speed. This one's a bit tricky. There's actually no work being done in this scenario, and we're gonna talk about that a little bit later. And then a rocket accelerates through space. The rocket is moving due to a force, and it is able to measure it. So that is work being done. There is an equation, like everything in physics. There's the equation for work, and that is force times distance times the cosine. And that cosine is going to be the angle between the force and the displacement. And we're going to look at a couple examples. The unit for work is going to be joules, which is represented as a capital J. So here are the examples of which work can be done. The first one is if the force and the displacement are in the same direction, meaning the force causes the object to move in the same direction as it. That would mean that there is no angle, so cosine 0, put that in the calculator and you actually get 1. So anything times 1 would be itself. So when trying to find work for an object that was moved in the direction the force was, it's just force times distance. No angle is necessary. Then we can look at what happens when the force basically slows down the object. It's in the opposite direction of that force. So if there's displacement and a force in the opposite directions, that would be 180 degrees. Cosine 180 is -1. So essentially, if this is a scenario, it makes your answer a negative, basically representing negative work. And again, negative work is when something is slowing down an object. The force doesn't cause the displacement, but it hinders it. And this is, again, negative work. 180 degrees would be -1 when you do the cosine, and that value basically just turns into a negative, representing negative work. Then we have a force that is applied in a 90-degree angle of the direction or the displacement of the object. This would be cosine 90. Cosine 90 is 0. Anything times 0 is 0, meaning no work is being done in a scenario like this. As we go back, we can look at that waiter question we talked about, who carried the tray across the room. He is applying a force up to carry the tray, but he's moving horizontally. So the angle between the force and the displacement is 90 degrees. Cosine 90 will give you 0, and so 0 would be your work. Technically, no work in this scenario is being done because the force and the distance or the displacement is not in the same direction. When a force is exerted on an object at an angle, only part of that force is going to be calculated. So for example, if we have an object being pulled horizontally up, we're going to only look at that horizontal. So using the angle between the force and the horizontal is what angle we are going to be using when doing the cosine. you want to be careful. If an object's on a elevated plane, such as the picture that is seen, if you pull up, it's going to cause the object to be displaced in the same direction as that pull. So no angle is necessary when calculating this work. It would just be force times distance, and that would be your work. So here is a summary page to kind of sum up the different scenarios you may see when calculating work for physics. Again, the first one is when the force and the displacement are in the exact same direction. No angle is necessary, so the equation you're going to be using is force times distance. The second scenario is if the force is in the opposite direction of the displacement, aka negative work, slowing something down. That's going to cause your answer to become negative. Looking at the third is if the force and the displacement are essentially at right angles. The force is going up, the distance is horizontal. That would be cosine 90, which would give you 0, and no work is being done. And then the fourth would be looking at an angle. So if something has caused an object to be displaced at an angle, you're going to be using cosine that angle and multiplying it by the force and the distance the object moved. So now we're going to look at a couple of practice problems that you may see. So how much work is done by an applied force to lift a 15 Newton object 3 meters vertically at a constant speed? They don't give us an angle. So what we're going to be doing is essentially just force times distance to get our work. The force they give us is 15 newtons. And we're going to multiply that by 3 meters. Multiply those two numbers together, and your work is 45 joules. Looking at our next problem, a force of 50 newtons acts on a block at the angle shown in the diagram. And it moves at 3 meters. How much work is done? So looking at the diagram, we have 30 degrees. So our work is going to be our force times our distance, and this time we're going to be looking at our cosine, so the angle at which it was pulled. So the force they give us would be that 50. The distance would be 3. And then it'll be cosine 30. And again, when calculating this, you want to make sure that your calculator is in degree mode, not radian. So 50 times 3 times cosine 30 should give you about 130 joules. So your answer is 130 joules. The next practice problem is Ben carries a 200 Newton suitcase 3 flights of stairs that has a height of 10 meters, then pushes it horizontally of a force of 50 newtons at a constant speed of 5 meters per second for a horizontal displacement of 35 meters. How much work does Ben do on his suitcase during this entire motion? So looking at work, again, it's force times distance times cosine if it's given an angle. We have the force of the suitcase, we have that distance for the first part, the force of the second part, and the distance of the second part. So what we're going to do is work for the first part, him going up the stairs, is 200 newtons. That's our force. And then the distance is 10 meters. We're going to multiply that together to get 2,000 joules of work. The second part would be the force, which was that 50, and 35 meters was the distance. We're going to multiply that together to get 1,750. And we're just going to add those two together to get the total, and that's going to be 3,750 joules. So you're going to be now practicing it by yourself with the worksheet that I have provided for you. And that is it.